Okay, hello everybody. For those of you who do not know me, I am Mrs. Hurley. I am the third Algebra 2 teacher this year. This video is going to talk about, it's titled Video 1.1.3. It's on page 5 of your notes, as you will see on the screen. And what we're going to do today is basically combine what Mrs. Punzel taught you in video 1.1.1 and what Mrs. Bartness taught you in video 1.1.2. So, just as a recap, reviewing what Mrs. Punzel taught you about the domain being the x values and also then the y, the range, over here on the right, being your y values. We need to know those, okay? They're the input, the output, so forth, a bunch of different words that you were taught. But when you hear the word domain, you really do have to know that we mean the x values. So we have a bunch of examples down here at the bottom, and for each of them, we are going to identify the domain and the range of the set, the function, okay? If it's continuous, it says that we want to use interval notation, which Mrs. Bartness taught us in video 1.1.2. Remember, the parenthesis is like an open, it's not included. The bracket is closed, it is included, and you have the infinity and negative infinity also. So let's take a look at number 1. If I am taking a look at this is just a bunch of ordered pairs in a relation. So if I'm looking to find the domain, I am looking at every one of these x values in each ordered pair. So if I have to then go ahead and list what the domain is, and I'm just going to use the letter capital D to represent domain. It is a set of numbers, so I do have to use set notations, set brackets. But what you want to do in that list is order them from smallest to greatest. And you never want to duplicate a number, okay? It's just like when our mapping, which we will talk a little bit more about, but you only list everything once. So smallest number I see there for my x values would be 1. If you want to go ahead and cross them off as you're listing them so that you don't duplicate or forget anything, 2 is the next smallest number. Then I have a couple of 3s, but remember, I'm only going to list them once. And last but not least, I have a 4. So that would be my set to represent the domain for this relation. Then I'm going to go in and I'm going to take a look at my range values, which again are my y values. And I'm going to make that list. And again, starting from the very smallest number to the largest number without duplicating any number. So I see negative 16 as the smallest number, then negative 9, then negative 4, negative 1, and last but not least, 2. So that would be my range and my domain for this relation or function. Now, remember, we talked about, or Mrs. Punzel talked about that mapping. If I wanted to go ahead and map this information, what I would do is I would list all of my numbers in one circle to represent my x's or my domain. That would be 1, 2, 3, and 4. And then do the same thing for all of my range values or my y values. That is negative 16, negative 9, negative 4, negative 1, and 2. And what ends up happening is it maps every single one of those x values and puts an arrow to what y value it belongs to. So from the first ordered pair here, it's 3, 2. So from my 3 to my domain, I'm going to draw an arrow to the 2 for the range. Then 1, negative 1. From 1, I'm going to draw an arrow to negative 1. From 2, I'm going to draw a picture to negative 4. From 3, I'm going to have another arrow, but that's okay. I got to go from that same 1 to negative 9. And then from 4 to negative 16. So that is a way to help you identify if the function or if the relation is a function or a one-to-one. You can see that here this would not be a function because I do have duplicate x values. Okay? Now, from that same thing then, I'm going to do the reverse for number 2. I have all of this information for the mapping, and I can go ahead and list the domain and the range. So if I start with my domain, these just represent ordered pairs. Okay, I don't want to take the time to list them, but the domain, again, is the set of numbers that includes -2, 1, 3, and 4.5. Doesn't matter that 4.5 has 2 arrows off of it. It just means that if I were listing the ordered pairs, 4.5 would be the x value for 2 different ordered pairs. The range then is just going to be the set of numbers that represent the y values, which would be 1, 2, 3, 4, and 5. Okay? If we take a look at number 3, this is a continuous function. It keeps going on. So this is what we were talking about. We need the interval notation that Mrs. Bartness talked to you about. So the domain represents, again, the x values. So we need to look at what values of x are represented from this function. So I'm going to go ahead and highlight this point and that point because those are the two that are the end points. From there, I'm going to draw just a dotted line down so that I can see where those values actually are for x. Remember, x is the horizontal axis. So this function goes all the way from -3 to, if I count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, we just have to decide, are those values included or not? Okay? It doesn't really say with a closed, it's not really that exact with a closed dot or not. So I'm going to go ahead and color this one in and leave this open just so we can see how that would look. So having said that, the domain then, the smallest the x value can be is -3. Now is -3 included? Yes, because it's a closed dot. So for that reason, I would have a square bracket. Then I'm going to go to 11. That's the farthest or the highest value x can be. Can it be included? No, because I put that open circle in there. So for that reason, it's going to be 11 with a parentheses. Now I'm going to do the exact same thing for the range, only this time it's going to be the y values, and y is the highest and lowest points. So now I'm going to highlight the very highest point and the very lowest point. Doesn't matter if we use the same point or not. So I'm going to draw my dotted line to see that this is 1, 2, 3, 4, 5, 6, 7, 8, 9 on the y-axis. That's the highest value. And then if I draw my dotted line over to the y-axis to see the lowest, -1, -2, -3, -4, and -5. My highest value is 9, my lowest value is -5. So those are going to be the numbers that are included in my interval notation for my y value. We always start with the lowest and go to the highest. But now I just have to decide if I need a square bracket or a parentheses on each one of those. The -5 is over here. That's an open circle. So for that reason, open means not included, so it would be a parentheses. 9, on the other hand, up here, that is closed. Okay, I didn't change it to an open circle, so for that reason, that would be a square bracket. Okay, why don't you go ahead and pause the video and try to complete number 4 with the domain and range. This is another continuous function, so it will have to be interval notation like we did in number 3. Okay, so let's take a look, see how you did. Let's take a look at, starting with my y value, or x values, the domain. Domain again is, I need the pen, not the highlighter. Domain is x, right and left. So what is my farthest right point? Well, that's right here. Now I want my highlighter. That's right there. And then what is my highest right point? That's right there, or farthest right point, So you'll notice that these two have arrows. Let's think back to algebra and geometry. What do arrows mean when you're given that ray or line? Hopefully you said that it keeps going forever and ever. So this doesn't stop like number 3 did. So for that reason, the domain, it's going to keep going in the left direction. So what do we represent with keeps going forever and ever and ever? That would be infinity, but because it's to the left, it's going to be negative infinity. Same thing on the right. Keeps going on forever to the right, so that would be represented by infinity. And like Mrs. Bartnett said, we can't define what infinity is, so therefore you would leave the open point. Now when it comes to range, this is different because there are some points that are of interest to us. We have the first one, which is the very lowest point down there. The very highest point is up here, the same as the domain, so we have to look at that one. And again, remember it has that arrow on it. So if I draw my dotted line over here to see the value, the lowest value the range can have is -2. Okay, so -2 would be the lowest. Now, can -2 be included? Well, yes, because there is a point on -2, so for that reason, it would be a square bracket. The highest value, like we said, was this 4, but it's an arrow. It keeps going. So for that reason, it goes on to infinity, and that would be an open circle or a parenthesis. Okay, that would be your domain and range. Now, number 5, last one. Add another ordered pair to this relation that would make this not a function anymore. What does a function mean again? That means you don't have any repeated domain values or x values. So if you take a look and you notice, if I'm looking at all of my inputs, x values or domain values, none of them repeat. I have a 5, an 8, a 7, a 0, and 10. So as it is now, it would be a function. But it says it doesn't want it to be a function anymore. So therefore, I would have to include a point that repeats one of those x values. Doesn't matter which one. So if I wanted to, I could just go ahead and pick 10 and then any value you wanted to for the y. So let's just say 1. That would make it so that it's not a function anymore because I have duplicating values of 10. I have a 10 here and a 10 here, not a function. It would only be a relation. Okay? Hope that helps. Let us know if you have any questions. Thanks.